Hello. So today we have another trigonometry practice video where I'm going to show that trigonometry does not have to apply only to objects, and it can apply to kind of more abstract concepts, however very real they are. So let's say we have a rock. This is our rock, and it's been thrown up in the air at some angle from the ground. This is angle, let's say, for our inconvenience again, 30 degrees, because that's an easy one. And it is traveling at some velocity, or you can imagine speed. Let's just say speed for now, because it doesn't really matter if it's velocity here. Let's say 7 meters per second. And we want to know how fast is it going upwards if we're not thinking about gravity, and how fast is it going to the side so that we can figure out what distance it travels. So this seems a little weird, right? Because it's a velocity and it's at an angle, and what don't angles have to do with the objects? And no, trigonometry applies to any right triangle of any kind. In this case, this is a vector. Because it's velocity and it has its direction, I'm just calling it speed for your convenience, trigonometry does definitely apply to it, and you can break it down into two separate vectors. Here, I'll actually color them differently. An arrow going in that direction, the horizontal direction, and an arrow going in the vertical direction. And if you're not familiar with vectors, I'll have some videos on my channel for you to check out. But basically, these two vectors go together to make this big one. It's a base and a height, and they make this hypotenuse here in a right triangle. So how can we find how much you move up in the y direction and how much you move forward in the x direction? Well, this is just trigonometry. We can just use our TOA. Which one can we use here? We know the hypotenuse, so it's easiest to use SO or ka. And we know the angle, so we can use either. It just depends on which side we want to find. So let's find both sides. How do we find the far side? Well, that's opposite side. So the sine of 30 is equal to this opposite side we want to know. Let's call this O. Is equal to opposite over the hypotenuse, which is 7. O, this is not a 0. This is an O over 7. So we can just easily solve for O. O is equal to 7 times the sine of 30. There we go. So we found O. We haven't solved exactly O. We don't know its value yet. We haven't simplified this sign here. How about this side? Let's call it A. What's the cosine of this 30? This is the adjacent A over that hypotenuse. A over the hypotenuse, which is 7. So similarly, we can solve for A. A must be equal to 7 times the cosine of 30. Now let's solve for these. I'm going to tell you the sine of 30 and the cosine of 30. The sine of 30 as you may remember, is equal to 1/2. And the cosine of 30 is equal to the square root of 3 over 2. Easy enough. So let's solve. So what is this first one equal to? 7 times sine of 30, 1/2, is equal to 3.5. That was easy. Now what units do we use? Well, we are working with meters per second, and sine has no unit. So 35 meters per second is the velocity, or think of it as the speed for now, that we're moving upwards. Now let's solve for the horizontal movement. Cosine of 30 is the square root of 3 over 2, so is equal to 7 times the square root of 3 over 2. And we can cancel that 2 and the 7, so 3.5 times the square root of 3. And I don't have this on hand, you can use a calculator, but this is our velocity in the x direction. And we're done. We've solved the problem. We know the velocity in the x direction and the y direction based on just an angle and a velocity outward down the hypotenuse. And you can think of how this can be very applicable to physics and problems in real life. Thanks for watching.